Today, we not only celebrate 30 years of operational numerical weather prediction at NCMRWF, but also mark a historic milestone, 150 years of the India Meteorological Department. IMD has been a beacon of excellence in meteorology, serving the nation with its dedicated weather services, and we take immense pride in celebrating this dual occasion with all of you. As we begin, I request our esteemed dignitaries to kindly take their seats on the dais. Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, and our chief guest. Sir, I request you to please come on the dais. Dr. Parvinder Maini, Scientific Secretary at the Office of the Principal Scientific Advisor to the Government of India. Dr. Mrityunjay Mohapatra, Director General of Meteorology, India Meteorological Department. Dr. Michael R. Farrar, Director, National Centers for Environmental Predictions, USA. Dr. David Walters, Associate Director, Foundation Science at UK Met Office. Dr. V.S. Prasad, Head, NCMRWF. And Dr. Ashish Rautre, Scientist F, NCMRWF. Thank you, esteemed dignitaries, for gracing us with your presence today. May I request Dr. V.S. Prasad, Head NCMRWF, to welcome the dignitaries on the dais with a flower pot. As we gather to honor these milestones, let us invoke the blessings of wisdom and knowledge to guide us further. To mark the beginning of today's events, we now proceed with the ceremonial lighting of the lamp. I invite our dignitaries to kindly come forward and join us for this significant ritual.
This was slick. Sir.
Go first.
Okay. Yes.
Go, but
Now we will have a rendition of Saraswati Vandana to celebrate the goddess of learning and enlightenment.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रावृता या वीणा वरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युत शङ्कर प्रभृतिभिर्देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती नियशेषजाड्यां पहा शुक्लां ब्रह्मविचारसारपरमाम् आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदां जाड्यान्धकारापहाम् हस्ते स्फटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिं प्रदां शारदाम्.
With the light guiding our way, it is now my privilege to invite Dr. V.S. Prasad, Head NCMRWF, to deliver the welcome address.
Respected Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, Dr. Parveen Ramaini, Scientific Secretary, PSA, Government of India, Dr. M. Mahapatra, Director General, India Meteorological Department, and co-host of this workshop, Michael Ferrare, Director, NCMRWF and his team, David Walter, Deputy Director, Research and Operations, UK Met Office, Director Generals and their representatives of BIMSTEC countries and RIMES, Central Weather Administration, Taiwan, esteemed invitees, former heads, directors, and Director General of and colleagues of NCMRWF, I wish extend a warm welcome to all of you. We convene here today to celebrate two significant milestones: 30 years of Operation NWP in India and 150 years of India Meteorological Department. I trust that all the attendees have experienced a comfortable journey, and I hope that you have been graciously received by my colleagues. Your presence enriches this occasion, and we look forward engaging a fruitful event. I am delighted to welcome to the 30 years of Operational NWP in India at the National Center for Medium Range Weather Forecasting. NCMRWF was established by the Government of India as a special project in the year 1988 under Department of Science and Technology, and with a clear mission to develop a robust operational NWP system in our country. Indigenous initiatives of the NWP started way back 1960 in IMD and also IITM. But within 5 years of establishment of NCMRWF, we successfully operationalized NWP system with highly skilled workforce and also with remarkable achievements from the international collaborations from the international associations like NCAP. And we have the data pre-processing and post-processing and visualization from the CMWF, along with advanced data assimilation modeling system from NCEP NOVA, USA. And our team combined all the things to operationalize this NWP system. And the system was declared operational from 1st June 1994, when Professor U.C. Mahanti officially handed over the NWP charts to then Director General of Meteorology, Jane Roy. We could not celebrate that function in June due to general elections in India. Our co-host, Dr. Mahapatra, DJIMD, encouraged us to celebrate it and advised to make it a part of 150 years celebrations of the India Meteorological Department. And we thank Dr. DJ for this one. We express our sincere gratitude to our Honorable Secretary Ravichandran for enabling us to celebrate the significant event. His exceptional vision and steadfast support to have greatly empowered our MOS community and NCMRWF in particular to pursue a variety of impactful initiatives. Under his leadership, in recent years, NCMRWF made significant strides in implementing numerous administrative and scientific decisions, paving way to continued progress and innovation. I would like to express my sincere thanks to our distinguished guests for accepting our invitation and making the efforts to travel long distance to attend the event. Special thanks to our international collaborators, NCEP NOVA, UK Met Office, CWA Taiwan, as well as BIMSTEC partners, Bangladesh, Bhutan, Myanmar, Nepal, Sri Lanka, and Thailand. Last 3 decades, NCMRWF played a focal role in transforming India's weather forecasting capabilities by providing NWP products produced by the state-of-art models. As one of the first centers to deploy high-performance computing for NWP in the world, NCMRWF has grown not only as a center for national importance, but also became a regional leader in NWP, providing support to many countries in the region. I thank our former heads, directors, and leaders for their valuable guidance in the initial years and entire journey for this success. Through rigorous R&D, research and development, and national and international collaborations, great advancements were made in the data assimilation, modeling of their system, and NWP product generation, forever increasing user demands, including the novel applications. HPC availability to NCMRWF has significantly enriched, which helped to improve the accuracy and reach of its forecast. Even though the center was established to provide NWP guidance for the agriculture sector, NCMRWF has now catering various sectors of economy. The global and regional NWP model forecast, short range to seasonal lead time to provide to India Meteorological Department and many other stakeholders, including defense, energy, water management, and many more government sectors and private sectors. NCMRWF NWP weather prediction system provides a reliable and sharp probabilistic forecast. NCMRWF is not only using atmospheric models alone for NWP, but also has advanced the global and regional coupled models. The advanced data assimilation systems for atmospheric, land, ocean, and sea ice provides initial conditions for our models. Making use of variety in situ and remote sensing observations, including from new and novel instrument stations. And some RWF has to provide high resolution, long-term regional and global analysis, which is widely used worldwide for R&D. These remarkable advancements and achievements are direct results of outstanding and collaborative efforts from the administrative and scientific staff of NCMRWF. I extend heartfelt thanks to and congratulations to entire NCMRWF family for these impressive accomplishments. This year marks a significant milestone in our history of NCMRWF as we successfully spearheaded most substantial and prestigious acquisition of activity for MOS by securing 900 crore HPC systems with a combined capacity of 20 petaflops. Honorable Prime Minister Narendra Modi inaugurated HPC, Anurika and Arka at NCMRWF and IITM Pune, respectively, on 26 September 2024. The Government of India also announced 2,000 crore Mission MOSAM for diversifying meteorological observation network over India. The first one is to strengthen the NWP products and developments, and the other provides basic observational data for the model. These developments coincide with the 3 decades of operational NWP, 3 decades of operational NWP and 15 decades of IMD. The aim of Mission MOSAM is to make India a weather-ready nation. With this encouragement and support from the government, we all should strive to continuously improve its capability and also aspects of NWP to be forefront to cater ever-growing demand. With the valuable encouragement support from the government, we have great opportunity to enhance our capabilities in all areas of NWP. By doing so, we can effectively meet the increasing demands for forecasts. Jai Hind.
Thank you, Dr. Prasad, for your heartfelt words. Your vision and leadership continue to inspire NCMRWF as we embrace new challenges and pursue excellence in weather prediction. It is a proud moment for us to join IMD in celebrating 150 years of the India Meteorological Department, a cornerstone of meteorological services in India and one of the global leaders in weather science. To shed light on this historic milestone, it is my honor to invite Dr. M. Mahapatra, Director General of Meteorology, IMD, to address the gathering.
Good morning, namaskar to all of you. Respected Dr. M. Ramachandran, Secretary, Minister of Earth Sciences, Dr. Parminder Maini, Scientific Secretary, Office of the Principal Scientific Advisor, Government of India, Dr. Farrar, Director, NCF, Dr. David, Associate Director, UCAMET Office, Dr. Prasad, my dear friend and colleague, Head, NCMRWF, Dr. Ashish Rautray, former Director General of Meteorology, Tyagi Saab, former directors of NCMRWF, and former colleagues from NCMRWF, distinguished friends and colleagues from various countries, including the BIMSTEC countries, dear friends from IMD, NCMRWF, INCOES, IITM, Director IITM, Krishnan Saab, and various constituents of Minister of Arts Sciences, and colleagues from Minister of Arts Sciences itself, ladies and gentlemen. At the outset, I congratulate all of you on this auspicious occasion when we are celebrating 30 years of operational numerical weather prediction in India, which started in 1994. I also congratulate all of you for celebrating this 150 years of India Meteorological Department. So while we were discussing, Prasadji and myself, we thought that these two cannot be different from each other, and these two events should be combined and we should celebrate jointly. The basic principle is that the India Meteorology Department is an institution which is linked and associated with each one of us. It has been recognized as a meteorological fraternity in the country and outside. It is not limited only to India Meteorology Department or only to National Center for Meteorology Weather Forecasting, but it is the entire community which have worked, contributed, collaborated, and seen the success stories in the past, and also identified the gaps and planning for the future. So if you remember, the very beginning, it all happened towards 1857, even though we have the first observatory in 1785, the first observatory in Calcutta, taken by the amateur scientists. But afterwards, there were complete understanding by the people in the country that there should be a standard process of meteorological observations, there should be the exchange of data, there should be the collaboration among the various agencies working differently, and there should be some kind of inference drawn from the observations taken, which can be utilized for the well-being of the society. At that time, people were dying mainly because of the monsoons and cyclones. There are floods, droughts, and the cyclones, and these are the major killers. The people thought that if we do not have this type of mechanism in the country, we cannot. So therefore, when there was the first war of independence going through in the country, which is popularly called as Sepoy Mutiny in 1857, a group of people in Asiatic Society of Bengal was thinking about how to save the people from the natural disasters. So they were lobbying or fighting, you can say, another war of independence to establish the Meteorological Committee. But however, because of this war, Meteorological Committee could not come up. Rather, the meteorological observations were being taken up in an amateur format, stopped during 1857 to 1860. Again, Asiatic Society of Bengal wrote in 1860 to revive all these observations and to establish the Meteorological Committee. Then also it was not agreed. People thought that people are dying because of the water problems or the air problems, or you can say the environmental problems. They referred it to Sanitary Committee. The Sanitary Committee told that it is not our job, it is the job of a separate committee. There should be a separate committee. So then finally, British India decided to construct or constitute the regional committees. There are 4 provinces, that is Eastern, Western, Central, and South provinces. So 4 regional committees are formed, but these 4 committees could not deliver the objective. That data could not be exchanged, it could not be standardized, instruments could not be calibrated. Then finally, in 1862, Asiatic Society of Bengal wrote that if you do not establish National Meteorological Committee, people will die again due to the cyclone. It so happened in 1864, we had 2 very destructive cyclones. One caused the death of 80,000 in Calcutta and 40,000 in another 40,000 in Machilipatnam. So these 2 compelled the British government at that time to start the meteorological services. The meteorological services started in 1865 with the introduction of the port warning in the country. At that time, it is undivided India. So therefore, those who are present from other countries here, they can realize that. That was the beginning of the meteorological services. And for that purpose, it was standardized, and express telegram was introduced. The 7 observatories were created along the coast, and these observations were collected at 10 o'clock in the morning and at 4 o'clock in the afternoon. And these 2 observations are carried out, and by evening, the message was created, message was given to the Port Authority, first to the Calcutta port, and then it was given to the Government of India, and action was taken. So that's the beginning. And now you know how we have come up. Perhaps there is no sector left out from that story where the Ministry of Arts Sciences, through its organizations, are not providing the service. No one is left out. So therefore, we have come up with a slogan that Har Har Mausam, Har Ghar Mausam. That means each household should have access to the information on the weather and climate at any time, anywhere in the country. And that has been successful. It has been successful because of many reasons. One of the important reasons has been the evolutionary process. The weather forecasting, as all of us know, it is an initial value problem. If you do not have the current, the qualitative initial observations, you cannot have the forecast. So this understanding came in the very beginning. Even when the first meteorological committee was formed, and Henry Blanford was the Director General at that time it was a national reporter, he thought that the observation plays a key role, and he started with monitoring the observations, and first the long-range forecast came off based on the relationship between Himalayan snow cover and the Indian monsoon rainfall. With that beginning, we came up again with Walker, who identified various oscillations occurring in the globe by considering the various types of observations. And the first oscillation was discovered in the Southern Oscillation Index. We are proud of that, and now we are calling it the El Nino and Southern Oscillations. The discovery goes to British India at that time. Not only that, they also identified North Atlantic Oscillation at that time. So like that, various oscillations occurring in the atmosphere in Walker circulation alpha snow came into existence, and with those, they developed some kind of long-range forecast, and that is forecast of monsoon rainfall. In 1905 onwards, the forecast commenced, but however, major breakthrough came in 1950s when we transitioned from simple synoptic forecast, statistical forecast, climatological forecast to the dynamical forecast. While entire country was starting with 1930s, India Meteorology Department, which is contemporary to world meteorology organizations, was also gearing up to utilize the numerical weather predictions. 1950s, the then DG, Dr. P.K. Das, ventured into this area, and first paper was published in 1958 on numerical weather predictions. And thereafter, of course, there was lobby. There was failure of the forecast, and when we go through the history, the memoirs of various director generals, we find that they have been lobbying with the Government of India to improve the computational systems. India Meteorology Department was going to Planning Commission to access the computers. And finally, we succeeded. And as people say, 1 megawatt, the journey has gone from a few kilobytes or megabytes to now the 30 petaflop almost in the Ministry of Arts Sciences. So there has been contribution, therefore, each and every person as a meteorological community. It is not limited only in the Government of India or the Ministry of Arts Sciences, but there have been academic R&D institutes like, say, Indian Institute of Technology, then Indian Institute of Sciences, those who have contributed towards the beginning of the research in numerical modeling. Similarly, Andhra University, in the university level. So there are many pioneering activities in the universities, academia, and R&Ds. And finally, as we come to NCMRWF with the establishment of supercomputers in the country in 1988, 1989, a group of people from NCMRWF and from Indian Institute of Technology, like Professor Mohanty Saab, and a group of people from India Meteorology Department joined hand and established the numerical weather prediction modeling system in operational manner in the country, for which we are all taking the claim that we can predict any weather at any time, anywhere in the country. Not only the country, but also outside. We are providing forecast and running services now to all the countries in this region, be it BIMSTEC countries or South Asia or Southeast Asia or Middle East. So this success story has been possible because of the collaborations. And this collaboration is not only limited only to national collaboration, but the international collaborations. When we think about the modeling system, always we think about the NCF. The first, the modeling which came to the country is the quasi-Lagrangian model. It came from NCF, USA. You can say USA. Dr. Krishnamurthy Saab gave this model, And we should remember on this day that quasi-Lagrangian model was the first model which was taken in 90s. Before that, we have got the Kuiper, the climatic persistence model. That is, again, I will tell you, Kuiper has been developed based on the model which has been taken from USA. So this international collaboration also has helped us to develop our capacity with respect to the modeling systems. At the same time, there has been parallel storage which improved the initial conditions. There has been satellites since 1960s. India is fortunate at that time to receive a automatic picture transmission receiver from USA at that time, which was established in Colaba office, and therefore no cyclone went undetected. And gradually, this cyclone data got digitized, and then we utilized it in the models, and now you can see that we are providing 15 days forecast of the cyclones, and there is no cyclone is missed. And not only that, we are also providing the impact-based forecast for the cyclones, not only minimizing the loss of life to 0. In the last 2 years, you see Viparjaya is 0, and then Rimal is 0, and now Dana cyclone is also 0 death in the region. So therefore, it is a great success. Like the monsoon, there is a cyclone. Similarly, there is other severe weather like thunderstorms, heat waves, where there was no numerical modeling. And there has been numerical modeling, and IMD is among the 5 countries which is providing lightning forecast with the support of NCMRWF, IITM, etc. But I will tell you, the growth of NWP has been possible because of the establishment of National Center for Medium-Range Weather Forecasting. Though IITM was there earlier, these 2 organizations came up from India Meteorological Department, but the contribution of dynamical modeling system was rooted through National Center for Medium-Range Weather Forecasting. So there has been the statistical work, lot of statistical modeling, etc. from IITM, but in the latter half of the 2000s, again, dynamical modeling system came off in IITM, and now, as Prasadji told, we all work as a family. There is complete collaboration, there is seamless collaborations, and hence there is a seamless forecasting, starting from a location to the entire country, starting from few hours to the entire season. But still there are gap areas. We can improve it further by improving the various components of numerical modeling systems, at the same time by converting this modeling output into the services. So for this purpose, again, with the able leadership and guidance from all the secretaries from Ministry of Earth Sciences, we started with Professor Goel, who cemented all these organizations by establishing the Ministry of Earth Sciences. It has been further cemented by the Dr. Shailesh Naik Saab, then Dr. Rajivan Saab. Now it is being led by Dr. Ravichandran Saab. You can see that there is no gap among the organizations in the Ministry of Earth Sciences. As a result, we have gone further. It is not simply numerical modeling. We have gone to dynamical statistical modeling. Also, we have gone for the hazard modeling. At present, we are providing impact-based forecast, risk-based warning based on hazard modeling, impact modeling, and risk assessment in the country. But story is not ended yet. We have to go further to improve our accuracy. Therefore, as Dr. Prasad told, continuously Ministry of Earth Sciences is improving its capacity. And I am sure with all this type of evolution in technology, the scientific methods, the collaborations, cooperations among the various communities, we can further scale the new heights, and we will go for celebrating again, not only for 30 years, but also 40 years, 50 years, and so on. I congratulate once again all of you on this festive occasion and auspicious occasion. Thank you very much.
Thank you, sir, for your enlightening address and for taking us through the remarkable journey of 150 years of IMD. We are truly inspired by the continued commitment and advancements under your leadership, which have elevated IMD's standing globally and reinforced its vital contributions to our nation. To express our gratitude, I request Dr. Prasad, Head NCMRWF, to kindly present Dr. Mahapatra with a token of our appreciation. Now, I would like to invite Dr. David Walters, Associate Director, Foundation Science at the UK Met Office. Sir, may I request you to share your insights with us?
Namaste and good morning. Honourable Secretary, Director General, Scientific Secretary, distinguished and honoured guests, and dear friends and colleagues. It's a privilege to be asked to help open this meeting to celebrate 30 years of operational NWP in India and 150 years of the India Meteorology Department. Thank you for inviting me and my colleagues from the Met Office, as we're honoured to join you in your celebrations today. The importance of meteorology in India can't be overestimated. Looking back 150 years since the founding of IMD, it's hard to imagine how difficult our science must have been back in the 19th century. Since then, we've seen the formalising of weather observations, the use of the telegraph to distribute these. We've seen the dawn of airborne measurement, electronic computing, and satellite retrievals. And we've also seen the advancement of our scientific understanding of the weather and the building of the global infrastructure to support our numerical weather prediction and to share and communicate the inputs, outputs, and impacts of our forecasts. More recently, we've seen the growth in AI and machine learning, which has the potential to similarly revolutionise our prediction capabilities, even if this is in ways that we don't yet fully understand. In the last 30 years, NWP in India has come a long way, from grid spacings measured in hundreds of kilometres to grid spacings measured in hundreds of metres. NWP has been described as the quiet revolution, the continual improvement of our forecast skill and the ability to make prediction at finer scales in space and time has led to forecasts today that would have been unbelievable only 30 years ago. As you'll hear in my presentation later, in their contribution to our collaborative model development, NCMRWF and the Ministry of Earth Sciences are playing a leading role in developing extended range, subcontinental and urban scale forecasts and their links to atmospheric composition and air quality. This will benefit the people of India directly, but it will also contribute to our collective knowledge and help others across the globe. Forecasting the weather and its impacts is also becoming more difficult. Climate change is a global challenge, and we're starting to see the impact of climate change on day-to-day weather that affects our people, their livelihoods, and their infrastructure. By working together in advancing our weather and climate science through initiatives like the Weather and Climate Science for Services Partnership, India and the UK, as part of the wider global weather and climate community, can continue to ensure that governments, industries, and individuals have the knowledge that they need to mitigate climate impacts and to adapt to the new realities to build a safer future for everyone. We will continue to improve our ability to forecast the weather in the context of this changing climate and improve the communication of these forecasts to the public, the government, and the private sector. By working together, we can continue to build our capabilities and be a collective force for good in the world. So congratulations again from the Met Office and from the UK government on your success and achievements in the last 30 years and 150 years. And here's to the progress we can make in the 30 years to come. Thank you.
Thank you, Dr. Walters, for your insightful address and for sharing your valuable perspective on the advancements in meteorological sciences. I now request Dr. M. Mahapatra, DGM IMD, to kindly felicitate Dr. Walters as a token of our appreciation. It is now my privilege to invite Dr. Michael R. Farrar, Director of NCEP USA, to share his thoughts with us.
Well, good morning, everyone. It's my honor to be here to celebrate 150 years of IMD and 30 years of NCMRWF. Our counterparts here in the U.S. are NCEP, and during that 30 years, we've collaborated a lot on numerical modeling in particular. I note that One of the things that hit me when I came in to see all the beautiful flowers, this is a wonderful tradition you have in India. In the United States, we really do flowers for two occasions, weddings and funerals. But I think of the wedding part of it, that's the more happier occasion, and as a union. And I thought of the parallels between the union of the national centers and the IMD under Mose, the union between our partnership between the U.S. And a lot of countries as well as the UK, my friends are between the U.S. And India over the last 30 years. So collaboration internationally has been such a wonderful benefit for all of us. Your address also on the history was remarkable. Also, that very commonality between all of our countries. We started our weather services within 4 years of each other, officially, and for the same reasons, to respond to the deaths of unforecast events like tropical storms, which happened, of course, in India and the Indian Ocean, as well as on the eastern coast of the United States. The advent of the telegraph, where we could bring observations and finally be able to, in near real time, do an analysis. So all of our countries were standing up around the same time, and it's been really an honor for me to collaborate internationally, particularly with our friends here in India, with NCEP and on our modeling that have happened for a while. And I look forward very much to go ahead and continue the collaboration at NCEP over the next 30 years. It will not be me. I'll be retiring from federal service next month, and it's my honor to my last big trip to spend it with you, our colleagues in India. So thank you so much for inviting us. And I look forward to talking with you more later today. So once again, congratulations on a wonderful history and for the many years to come.
Thank you, Dr. Farrar, for your address and sharing your insights with us. May I now request Dr. M. Ravichandran, Secretary of Ministry of Earth Sciences, to kindly felicitate Dr. Farrar with a token of our gratitude. I would now like to welcome Dr. Parvinder Maini, Scientific Secretary, Office of the PSA, to the Government of India to address the audience.
Of the BIMS technicians, the entire meteorology community, friends, a very, very good morning to all of you. First of all, I would like to congratulate IMD on completing 150 years of service to the nation. IMD, being the National Weather Service, is of course, agency is committed to provide a very, very reliable, accurate weather forecast in all temporal and spatial scales. And of course, its forecasts are improving by the day, and so are the challenges. We, of course, just heard from Dr. Mahapatra about the success stories of IMD. And IMD, of course, has stood by the challenges and has been giving weather forecast successfully to the entire nation as a National Weather Agency. So my congratulations to the entire community. Needless to say, the operational NWP models have played a very, very pivotal role in this entire journey. And as has been elucidated by Dr. Prasad, it was in 1994 when for the first time IMD started utilizing the output from the NCEP adapted numerical weather prediction model being run at NCMRWF. It was, of course, a landmark day for all of us, and because India officially adopted the NWP in the operational weather forecasting. Today, of course, marks 30 years of operational NWP, and I'm happy that I not only am part of this celebration, but I also contributed in some way during this successful journey. And in addition, of course, we had some very successful collaboration with our international partners. And I'm very happy that both Dr. David, Associate Director of UK Met Office, and Dr. Michael, Director of NCEP, are here with us to celebrate this momentous event. Now, of course, the launch of the Monsoon Mission, which helped us set up the Monsoon Desk at NCEP, and later collaboration with the UK Met Office on the UM partnership, paved the way for a seamless NWP system in India. And so over the years, although the way we forecast weather from analog to statistical to NW has changed, and for something better, but the ultimate goal for giving an accurate forecast at a particular location and for different weather parameters has remained unchanged. And this will, of course, remain unchanged for the years to come and will remain a challenge. As was actually mentioned by Dr. Prasad, NCMRWF was established in 1988 as a mission mode project, mainly to cater to the needs of weather forecasting in medium range scale for the farming community in India. So, of course, NCMRWF has a mandate to continuously develop next generation numerical weather prediction systems in terms of reliability and accuracy over India and neighboring regions for operational use by IMD. Of course, NCMRWF also doubles up as BCWC Center for Weather and Climate. So to achieve all this, government had set up some very, very tough goals for NCMRWF. And I, being part of NCMRWF right from its inception, have been a witness to some of the fiery discussions that we had in the rooms where very, very tough targets were laid out for us and with strict deadlines to achieve something unheard of in India. One such challenge was to provide location-specific forecast using NWP output at the 127 agroclimatic zones of the country for the benefit of the farming community. At that time, of course, the TAT model that were being run at a very coarse resolution of 150 kilometers, and getting a reliable and accurate forecast at a particular region from this model was not very easy. Therefore, to reduce errors and increase the accuracy of the prediction results of the NWP models, statistical post-processing was undertaken to account for the local environmental conditions. This was, of course, the only option available to us. So with the paper on Murphy and cards in our hand, Dr. Ashok and I, a colleague of mine who's no more with us, we set out to develop location-specific statistical dynamical models. Today at this platform, I will like to place on record the immense contribution made by Dr. Ashok in this field. These are, of course, early memories. Now, with the advent of faster computers, our dynamical models are being run at a much finer resolution. Today, NCMRWF is running a myriad of models from global to regional NWP models. Global and regional coupled NWP systems are also being run to cater to the needs of IMD and neighboring regions. A seamless weather prediction system has been established to give forecast in all ranges. However, the uncertainty in NWP model prediction still remains a challenge. The global ensemble prediction systems being run operationally and elsewhere in the world, which are giving probabilistic forecast, have tried to at least address some of the uncertainties. However, the model forecasts still suffer from systematic bias and dispersion errors. Scientists in the world are trying to figure out how to address this. Of course, statistical post-processing methods have again found a way, and ensemble model output statistics are being run to account for some of these biases. Now, of course, today ensemble prediction has become an integrated part of weather and climate forecasting, but the challenge to communicate this probabilistic forecast is much, much difficult compared to a deterministic forecast. Now, over the years, with rapid expansion of various types of data from various observing platforms, improved data assimilation techniques, increased computing infrastructure and the computing capabilities, better understanding of the atmospheric dynamics, advancement of NW systems models, and sophisticated post-processing methods has led to delivery of more accurate forecasts, including extreme weather events such as severe thunderstorms, heavy precipitation events, heat waves, and so on. Today we are also talking about, as was mentioned by Dr. David, we are also talking about AI-based models. With the increase in the frequency of extreme weather events globally, many players such as Google and IBM have actually started developing cutting-edge weather forecasting models based on artificial intelligence to give a more precise weather forecast in the shortest of times. Added to this, with climate change, the way weather occurs and behaves is actually changing, and therefore weather prediction capabilities have to continuously evolve to address these new challenges that come. In addition, the expectation from public is also increasing. Today, people look for reliable forecast in all ranges and for all kind of weather prediction models, systems from weather agencies. And therefore, the operational agencies are actually facing lot of pressure, not only to demonstrate value in the forecast they issue, but also they are accountable for what forecast they give in the aftermath of, especially of an extreme weather event. In addition, they also have to face competition from other players in the field. So in summary, I would like to say in the 30 years of operational NWP, there is a reason for us to cheer, because this has not only changed the way we predict the weather and the way we forecast weather in a more reliable and accurate way, it has also changed the perception in the common man's mind. Now the common man looks for a weather app to see what is the weather before they move out. This was not so 30 years back. So the reliability, of course, has given by the National Weather Agency has actually developed a lot of confidence among the common man to rely on the weather agencies. So I once again congratulate NCMRWF, IMD, and the entire meteorology community for this wonderful day that we are all celebrating together. Thank you so much.
Thank you, Dr. Maini, for your inspiring address and for taking us through the development journey of operational NWP in India and the role of NCMRWF and IMD in it. We are deeply grateful for your continued support and guidance, which play a vital role in advancing the mission of NCMRWF and India's leadership in weather science. I now invite Dr. Prasad to kindly present Dr. Maini with a token of our appreciation. The inauguration of the cloud server at NCMRWF marks a major step in enhancing our computational and data management capabilities, further advancing our contributions to numerical weather prediction. May I request Dr. Ravichandran to kindly do the honors.
Welcome to an exciting new chapter in the evolution of weather forecasting and climate science. Today, NCMRWF, the National Center for Medium Range Weather Forecasting, is entering the world of cloud services with NGC Cloud. We're taking a big leap forward by moving our systems to the cloud. Our FTP server now offers unmatched scalability and security, making file access easier than ever. Our web server is supercharged for faster, more reliable site access worldwide. The API server is primed to deliver critical data swiftly and securely to our user agencies. And with our GIS server in the cloud, we can create dynamic, interactive data visualizations that transform analysis. This migration means faster, smarter, and more powerful performance across the board, setting us up for a future-ready digital experience. In a world of ever-evolving security needs, enter our new SFTP server. Log in with your credentials and experience unparalleled security, with seamless, reliable access to all your files. In a groundbreaking leap forward, we bring you the newly designed NCMRWF website, now hosted on a powerful cloud server. Faster, more secure, and crafted for seamless access to critical weather data. Experience the intuitive new homepage, reimagined to provide the latest forecasts and insights at your fingertips. Introducing our indigenously developed geospatial server, now hosted on the cloud to transform weather analysis. This powerful platform delivers interactive, dynamic visualizations of NWP model, specifically designed to manage weather data in a detailed way. Experience a new level of precision and clarity in weather insights, powered by advanced tools for analysis and interpretation. With real-time data processing and seamless integration, this platform provides unmatched accuracy for decision-making.
Next, we are proud to present two significant publications. First of them is an e-book of memoirs which brings together the reflections and experiences of key individuals, former heads and directors who have been instrumental in shaping NCMRWF's journey. May I request Dr. Ravichandran to kindly do the honors and release the e-book. We also have a souvenir for the 30 years of operational NWP in India in the form of a book, which is a comprehensive volume commemorating the development of NCMRWF, showcasing its key features, activities, and contributions in the field of operational NWP over the past 30 years. We have recently made a movie in order to commemorate the 30 years of the development of operational NWP, and it highlights the significant contributions from IMD and NCMRWF.
Aditya Jayate Vrishti. From the sun, the rain is born. In a land as diverse and weather sensitive as India, predicting the weather is no small task. From the bustling urban centers to the vast rural landscapes, the monsoon rains, heat waves, and cyclones significantly impact the lives and livelihoods of over 1 billion people. But how do scientists predict these powerful weather systems with enough lead time? Numerical weather prediction, NWP, a field where science, technology, and advanced mathematics converge to forecast the future of our atmosphere. This short film takes us behind the scenes of India's journey with NWP, from early forecasting methods to today's cutting-edge techniques, employed by supercomputers and a vast network of observation systems. With insights from India's premier meteorological institutions, we explore how data from satellites, radars, and weather stations are transformed into predictions that help protect lives, support agriculture, and serve many sectoral applications. NWP is the best suited tool to forecast, considering all time scales ranging from seasonal to nowcast. The dawn of NWP in India and India Meteorological Department may be traced back to 1958, when the first paper entitled Numerical Prediction of the Movement of Bay Depressions, was published in the Indian Journal of Meteorology and Geophysics, authored by Dr. P.K. Das. During that period, a significant challenge was the absence of an adequate computing system, a third-generation mainframe computer system, which facilitated the initiation of operational numerical weather prediction at the India Meteorological Department (IMD). National Center for Medium Range Weather Forecasting (NCMRWF) was established in 1988 after the severe 1982-83 El Nino drought to strengthen India's medium-range weather forecasting capabilities. A major boost to NWP in India occurred in 1988 after India had its first supercomputer, Cray XMP-14. At present, NCMRWF under the Ministry of Earth Sciences develop and disseminate medium-range weather forecast predictions spanning from 3 to 10 days. NCMRWF has advanced data assimilation systems for making initial conditions for its global and regional models using observations from various providers like IMD, NOAA, ISRO, UMETCAST, and also various real or near real-time ocean and sea ice observations. NCMRWF has achieved remarkable advancement in its NWP capabilities over the past 3 decades, evolving from making global forecasts with a resolution of 150 km to achieving 12 km resolution. Additionally, it has been working on an experimental global NWP model with a 6 km resolution based on NCUM. Early results from this high-resolution model demonstrate enhanced forecasting abilities, particularly in capturing tropical convection. High-resolution regional models are essential for capturing localized weather phenomena with greater accuracy, enabling precise forecasts critical for disaster management, agriculture, and urban planning. The evolution of regional models reflects this need, progressing from early systems like the spectral and ETA models to advanced tools such as NCUM, regional and high-resolution rapid refresh. Ensemble modeling at NCMRWF provides probabilistic forecasts by capturing uncertainties through multiple simulations, aiding decisions for extreme weather and critical sectors. In 2018, it set a global benchmark by upgrading its ensemble prediction system to an unprecedented 12 km resolution, the highest in worldwide at that time. A dynamical approach for S2S predictions using the global atmospheric model posed with observed sea surface temperature in the late 1990s. From there, we have evolved to the current 60 km global coupled model. NCMRWF developed both global and regional reanalysis capabilities. NCMRWF serves as the BIMSTEC Center for Weather and Climate, fostering cooperation in weather modeling research among member countries. It also supports the RIMES Climate Service value chain through capacity building initiative. The center extends its support across multiple sectors, including renewable energy, water management, and agriculture, addressing the needs of both private and public entities. The center is also committed to skill development and capacity building, encouraging the next generation of experts in numerical weather prediction and data analysis, including students, researchers, and professionals. The NCMRWF under the Ministry of Earth Sciences is proof of India's commitment to advancing weather science. It marked a pivotal moment in India's approach to meteorology, aiming to enhance weather prediction capabilities for the country through advanced scientific research, technology, and collaboration. Thanks for joining us on this exciting expedition into weather prediction.
It is my privilege to introduce our chief guest, Dr. M. Ravichandran, Secretary of the Ministry of Earth Sciences, Government of India. Dr. Ravi Chandran is a distinguished scientist with extensive contributions to the fields of oceanography, climate sciences, and Earth system modeling. Under his leadership, the Ministry of Earth Sciences has spearheaded numerous initiatives to enhance India's capabilities in weather prediction and climate research. We are honored to have him today with us. Sir, please.
Dr. Michael Ferrer, NCMRWF, and his team from NCMRWF, David Walter, UK Met Office and his team, Taiwan delegates, BIMSTEC governing body members, Dr. Parvinder Maini, Dr. Mahabatra, Dr. Prasad, Dr. Asis, and former Director Generals of India Meteorological Department, and former heads and directors of NCMRWF, MOES institution directors, colleagues and friends from MOES, and other invitees. Very good morning to all of you. Of course, indeed, it's very great pleasure to be here as part of this particular celebration about 150 years of IMD contributions to the nation, as well as NWP, operational NWP of contribution by NCMRWF. First and foremost, I congratulate both organizations for their immense contribution to the nations. I think they have come a long way, and from many people have already explained how it has been evolved over the period, especially for the operational forecast system of weather and climate, as well as how the numerical weather predictions has contributed to the operational weather forecast system. Since many of our colleagues has already mentioned about whatever they have contributed and what is the contribution from NCMRWF as well as IMD. So I will restrict my talk very brief. Of course, the last 1 year, the major initiative or major initiative by Government of India has contributed is high performance computing system as well as Mission MOSAM has been very important achievements, of course, contribution from all these organizations. As you all know that the Ministry of Earth Sciences works in all 5 spheres, especially atmosphere, hydrosphere, geosphere, cryosphere, and its associated biosphere. All the 5 spheres work in holistically. I am proud to say that I think considering the Mother Earth, its contribution as well as to take care of this Mother Earth, one of the ministry, of course, Government of India has realized to keep a Ministry of Earth Sciences to look holistically all this Earth system. I think now the way it goes, the weather prediction onwards, everything, if you talk about it, initially we started with the atmosphere, then we coupled with the ocean, then we coupled with the cryosphere, then it is going all the way, it is complete Earth system, maybe the biosphere, everything Earth systems coming. So we are inching towards Earth system approach. So that is whether we have to go forward in the future. I think that has been well recognized by our 4 secretaries, that means former secretaries as well as directors, so that we are able to realize very soon in the coming years. I think when you talk about IMD, I think it has significantly contributed. Of course, in the ministry, ministry means especially in the forecasting system, we always feel that 4 pillars for the better forecast start from observations, and number 2 is understanding, number 3 is whatever we understood, try to model them and go for numerical or whatever the forecasting, and finally is forecasting and disseminations. So in India, basically the first and last mile, that means first and last leg of observation and forecasting is done by IMD. I think over the 150 years, they are able to contribute this particular endeavor. And the second understanding mainly from the Indian Institute of Tropical Meteorology, Pune, and its maybe many other institutions. And the main numerical forecasting, that means numerical modeling as well as the assimilation, is mainly spearheaded by the NCMRWF. So, but primarily they are leading these things, but it doesn't mean that they are not contributing in other sectors. in these 4 pillars, I think we have evolved. I think the numerical weather forecasting, we have a lot of collaboration with, of course, the 2 important countries. They have significantly contributed. So that is why even if you take a long-term, that means seasonal forecast, we have migrated from statistical to dynamical. That is the immense contribution from the collaborations of various ministries as well as the country abroad. When you talk about NCMRWF, I think they have started with recently they have started from long way. They have started with the coupled data assimilation, and there are about various model resolution. They have going zooming very high resolutions. Of course, they started with 150, so now maybe 100-meter seamless forecasting system they have developed. Then, of course, the various techniques of data assimilation they have initiated and developed and incorporated in the operational forecast model, and also ensemble forecast system, and also various kinds of verification system. That is one of the important aspects which uniquely they do it in NCMRWF. And also the forecast products for the various applications, various ministries and other things. So these are the general things which NCMRWF is contributing over the last 30 years. Of course, IMD, you no need to say that they have entire spectrum. Whatever NCMRWF is doing, so that has to be finally, it has to be translated, or it may be communicated to the public by IMD, whatever the science. Having said that, of course, there is a long way to go, as many people have already pointed out. So I will just briefly tell about what is the next course of action. Of course, we have done enough some of the things, and we need to go long, much more expectation from the users, especially the weather pattern also is changing so chaotically, both in terms of spatial resolution as well as temporal resolutions. So we need to have more and more observation, more and more understanding, more and more modeling techniques, assimilation techniques, and also dissemination chains, and maybe the way of how to disseminate the methodology or the methods we need to change in terms of social media and other things. So the first and foremost, of course, we need to go for still very high resolution models, the global models, because we need to go for, especially in the tropics, we need to go for maybe at least a cloud solving scale we have to go, unless otherwise we cannot go for such a low, that means high frequency spatial time scale, high frequency, that means high resolution models, because each what is called within even 6 kilometers there are a lot of variability. So we need to go much more, and hence we need to go for high resolution models, and also we need to go for much more the coupled data assimilations. So I think you have initiated, but we have to improve various couplers as well as the assimilation techniques. We need to go on improve, and as others have pointed out, it is not only the physics-based numerical model will help, because there are approximations and errors. We need to substitute that with the data-driven AML or data analytics. We need to, or big data analytics, we need to incorporate, so that we have to fuse them both, numerical as well as AML technique, so that we can improve the forecast. And also we need to have more and more ensembles, so that we can reduce the uncertainty in our forecast. And also the computing. Of course, we are going with the, of course, numerical model with the CPU, now AML with the GPU. Now also we need to think about a quantum computing. Also we need to slowly start to incorporate our numerical weather code into the quantum machine, so that we can seamlessly, we can switch over from one to another, and we should not be devoid of such technological resources. And also finally we need to think about what is our plan for in 2047, where we need to reach. That means in 2047, whether this system approach forecasting system, for that, what is that our milestone, what we need to achieve, that we need to define. So I think maybe separately, both the NCMRWF as well as IMD separately, we need to make their own vision for 2047, and collectively as a weather and climate forecast, what we need to do as a country, we need to plan for 2047 vision. For that vision, it is imperative that next 5 years, we need to build the infrastructure for the meeting that vision of 2047. Either you talk about compute resources or observational resources. Mainly, we need to more and more focus about our observational resources we need to strengthen, and also various techniques, whatever the technologies come in the way, we need to grab it and utilize for our operational forecast. And most importantly, I would again urge that we need to have more and more collaborations. I mean, collaboration means within the institute and within the ministry, within the country, and maybe country outsides. And within the country also, not only for the institutions, but also we need to involve the academia, and we need to involve the industries, and we need to involve various academy and other institutions abroad, so that we can collectively, because weather system is, it is not a one or one institute will solve. I think we need to learn from each other, and we need to contribute to each other so that we can grow much more better in the coming years. Of course, finally, our dream should be how we can make that new generation Earth system model for the benefit of all the societies, right from various time scales, from seconds, even the lightning and other things onwards, maybe the climate time scale, how we can cater, as well as we always have a dream to go from the panchayat level to various regional level, how we can go for the operational forecast. For that, I'm sure that numerical weather prediction has to play an important role along with the data simulations, and also the observation requirement of IMD, because not only for radar, and we need to probe the vertical profiles as well as various satellites requirements, we need to augment so that we will better observe, and so that we can reduce the initial conditions of initial errors of the model or whatever the things in the Earth system, so that we can have a better forecast. With this, I request all of you to contribute together, collaborate together, so that we collectively we do science and translate that science to the benefit of society in the coming years. Thank you very much. Thank you for inviting me.
Thank you, sir, for sharing your invaluable insights and vision for advancing meteorological and climate services in India. We deeply appreciate your leadership and the support of the Ministry of Earth Sciences in driving significant progress in this field. May I request Dr. V.S. Prasad to felicitate Dr. Ravichandran with a token of our appreciation. Over the years, NCMRWF has been shaped by the vision, dedication, and hard work of its leaders. On this occasion, we want to honor and felicitate the former directors, heads, and dignitaries who have contributed immensely to this journey. I now invite Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, to felicitate our former directors and heads. May I request the dignitaries to come forward for this special moment of recognition and gratitude. Dr. Santosh Kumar Mishra. He was the first Director General of NCMRWF. Dr. S.K. Mishra was the first Director General of NCMRWF during 1993 to 1996. He was instrumental in establishment of NCMRWF, driving the installation of India's first supercomputer, the Cray XMP, in 1988, and introducing the data simulation system in collaboration with NCEP. His efforts Professor U.C. Mohanty was the Joint Director Research from 1993 to 1995 at NCMRWF. He spearheaded the installation of India's first supercomputer, Cray XMP, at NCMRWF, enabling nationwide agro-advisory services a week in advance and marking a significant leap in India's operational NWP capabilities. Dr. R.K. Paliwal served as the Research Division Head at NCMRWF. He joined NCMRWF after retiring as the Air Commander from the Indian Air Force. He was pivotal in improving the forecasting system at NCMRWF by primarily focusing on data simulation and numerical weather prediction.
I can come there.
Dr. Paliwal's expertise in enhancing weather forecasting accuracy through advanced data assimilation techniques has greatly helped India's numerical weather prediction systems. Dr. R.K. Datta was the project coordinator at NCMRWF during 1988 to 1993. He is one of the visionary founders of NCMRWF who pioneered medium-range weather forecasting in India by benchmarking the nation's first supercomputer, the Cray XMP. He was instrumental in establishing state-of-the-art facilities, fostering global collaborations, and initiating daily operational forecasts, transforming agro-advisory and weather services. Dr. A.K. Bohra was head NCMRWF during 2005 to 2010. Dr. Bohra played a pivotal role in shaping NCMRWF during its formative years by contributing significantly to global forecasting advancements. As head of NCMRWF, he led initiatives such as strengthening scientific collaborations, advancing probabilistic and seasonal forecasting, and established the BeamStack Center for Regional Weather and Climate Services. Dr. Harinder Prakash was head NCMRWF during 2010 to 2011. He joined NCMRWF in December 1989, and during his tenure with a team of about 40 young scientists from diverse disciplines, NCMRWF tackled many multidisciplinary challenges, often requiring innovative problem solving and collaboration. Dr. Harinder Prakash emphasized the importance of balancing core competencies with adaptability to achieve meaningful results. Dr. Swati Basu served as Director NCMRWF during 2012 and 2015. She played a pivotal role in operationalizing India's first global NWP model, which assimilated land, ocean, and space data from across the globe in real time to generate forecasts. She also strengthened collaborations with global NWP centers, initiated the BeamStack NWP Guidance Center, and fostered partnerships both nationally and internationally. Dr. E.N. Rajagopal served as head NCMRWF during 2016 to 2020. Dr. Rajagopal significantly advanced NCMRWF's modeling capabilities. Under his leadership, the GFS at T254 resolution was introduced and was later upgraded to T574. He played a pivotal role in operationalizing the Unified Model Partnership with the UK Met Office. Dr. A.K. Mitra was head at NCMRWF during 2021 to 2022. He played a pivotal role in the development of NCMRWF as a mission mode project during 1988-89, enabling India to become the first in South Asia with real-time global medium-range weather forecasting capacity. Collaboration lies at the heart of progress in meteorology and climate sciences. The long-standing partnership between the UK Met Office and Ministry of Earth Sciences exemplifies how the exchange of knowledge, expertise, and resources can drive innovation, enhance forecasting accuracy, and address complex global challenges like climate change. By working together, we have not only advanced numerical weather prediction systems, but also strengthened our collective ability to deliver impactful, science-driven solutions for the benefit of our nations and the global community. On behalf of the UK Met Office, Dr. David Walters would like to honor the Secretary, Ministry of Earth Sciences, for his visionary leadership and unwavering support in strengthening the collaboration between the UK Met Office and the Ministry of Earth Sciences by presenting a token of appreciation. Dr. Walters would also like to honor DGM IMD. Dr. Walters would also like to acknowledge DGM IMD for his significant contributions to advancing meteorological services and fostering this impactful partnership. Finally, Dr. Walters would like to honor Head NCMRWF for his pivotal role in facilitating this collaboration and driving innovation in weather prediction with a token of appreciation. We deeply appreciate the UK Met Office's steadfast support and collaboration with NCMRWF, which has significantly strengthened our forecasting capabilities and mutual growth in this critical field. As we approach the conclusion of this grand celebration, I invite Dr. Ashish Rautre, NCMRWF, to deliver the vote of thanks.
Good morning, everyone. As we come to the conclusion of the inaugural session of this enriching workshop commemorating 30 years of NWP at NCMRWF and 150 years of the IMD, it is my honor on behalf of NCMRWF to extend a heartfelt thank you to everyone who made this event a success. Firstly, I would like to express our deepest gratitude to our esteemed chief guest, Dr. M. Ramachandran. Since Secretary, MOS, Sir, your inspiring word and insight on the advancement in meteorological science have not only set a high benchmark for us, but have also motivated us to continue pushing the boundaries of weather and prediction. I also extend our sincere thanks to Dr. M. Mahapatra, DGM, IMD. Your deep knowledge and dedication to enhancing India's meteorological capability have been a guiding light for us all. We are truly grateful for your presence and continued support. Thank you, sir. Our heartfelt appreciation goes to Dr. Michael R. Farrar, Director of NCEP, and Dr. David Walters, Associate Director, Foundation of Science, UK Met Office. Your contribution and collaboration between our institutions have been invaluable in our journey towards improved NWP. We look forward to strengthening this bond and learning from each other's expertise. We advance in this field together. A special thanks to Dr. Parvinder Mini, Office of the Scientific Secretary, Principal Scientific Advisor, Government of India, your guidance and support in scientific initiatives continue to be pivotal for our research and operational work. And we are grateful for your presence here with us now. To our respected Dr. V.S. Prasad, Head of NCMRWF, thank you for your leadership, vision, and encouragement that have enabled us to host this significant workshop. I would like to extend a special thank you to all of the former directors, head of NCMRW. Your invaluable contribution and dedications over the year have been instrumental in building this institute. It is because of your hard works and vision and that NCMRW has grown to where it stands today, and we are truly grateful for your legacy, sir. I would also like to recognize the efforts of our administration, Mr. Biswajit Guha, DS, Mr. Asutosh Srivastav, SO, Ms. Pragya Joshi, SFO, Mr. Harish Khati. Organizing an event of this scale is no small feat. And the hard work behind the scene ensure everything ran smoothly. We deeply appreciate their dedication and commitment. I would also grateful thanks to Dr. Kamaljeet Rai, Program Director, and without her help, we cannot move to organize this large-scale workshop. Thank you, ma'am. I would like to particularly recognize my colleagues here at NCMRWF. The success of this workshop is a testament to our hard work, meticulous planning, and attention to details. Your dedication and teamwork have been invaluable. Thank you for being so helpful, supportive, and commitment to excellence. Finally, I extend my gratitude to all the participants from ABOR, NCEP, UK Met Office, and BIMSTEC countries, attendees, colleagues from IMD, and speakers. Your involvement and active participation have added great value to our sessions and foster an environment of learning and collaboration. Lastly, if I have missed mentioning anyone in this list, please know that your contribution have not gone unnoticed. And we are truly grateful for everything you have done to make this workshop a success. Thank you once again to everyone for your presence and contributions today. May this workshop inspire new ideas and foster lasting partnership as we towards a better understanding of weather prediction. Thank you. Jai Hind.
Thank you, Dr. Rautre. Ladies and gentlemen, may I now request everyone to please rise for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
This brings us to the conclusion of today's program. May I now request all of you to join us for a group photo to commemorate this momentous occasion. After that, I invite all of you to join us for high tea and continue the conversations as we celebrate this milestone together. Thank you for being a part of this special day. Have a wonderful day. To the front of the main building, to the entrance.
We'll have to walk to the reception.
Back to the reception. ठीक है, डीके सर का भी दे दीजिए। लोग CPTs वगैरह भी लोड